Okay, so welcome back everyone. Today we're gonna solve this particular question of the name of the question is minimum cost to the uh, fill given weight in the bag, right? So today marks our day 647 of the problem solving streak. So let us quickly move ahead to the question now. So let me get back to my tab screen. Okay, ठीक है तो वापस से वैसे ही शुरू करेंगे. We will highlight the points which are required to solve this question. So we've been given a bag of size WKG and we are providing the cost to package different weights of oranges in array cost, right? तो देखो ये जो cost है ना यहाँ पे इंडेक्सिंग करो 0 1 2 3 4 5 1 बेस्ड इंडेक्सिंग करे तो एक्चुअल में 0 बेस्ड होता है, राइट? तो इसका कहने का ये मतलब है कि द कॉस्ट ऑफ 1 kg ऑरेंज इज प्रेजेंट एट इंडेक्स 0 एंड इन जनरल एरे ऑफ आई रिप्रेजेंट्स द कॉस्ट ऑफ i+1 kg. मतलब कि इफ यू वांट टू बाय 5 kg 4 kg ऑरेंजेस देन द कॉस्ट वुड बी 50. सिमिलरली इफ यू बाय 3 kg ऑरेंजेस द कॉस्ट वुड बी 4. द टास्क इज इफ और एक और कंस्ट्रेंट है, इफ द कॉस्ट इज -1 मींस दैट i+1 kg पैकेट और ऑरेंज इज अनअवेलेबल. मतलब कि यहाँ पे अगर इंडेक्स मार्क करो 1 2 3 4 5, then if you want to buy 5 kg oranges then it is not possible. You can only buy oranges of 3 kg and 4 kg at once, right? So it may be assumed that there are infinite supply. ठीक है यार, infinite supply है, इस पॉइंट को भी नोट किया जाए. And हमें निकालना क्या है? We need to find the minimum total cost of buy exactly k WKG ऑरेंजेस, राइट? ठीक है, तो ये क्वेश्चन पढ़ के यार अभी तक हमने इतना इतना क्वेश्चन सॉल्व किया तो आपको ये चीज तो हिट हो ही गया होगा कि दिस इज अ वेरिएशन ऑफ नैपसैक, राइट? एंड नैपसैक डीपी से बनेगा, उसके लिए हमें रिकर्जन समझेंगे प्लस मेमोराइजेशन समझेंगे, फाइनली हो जाएगा. बट ठीक है, इसको जीरो से भी शुरू करते हैं, जीरो लेवल से भी. तो कहना क्या चाह रहा है यार कि हमारे पास एक वेट एरे है, राइट? एंड वी हैव लेट्स सेट. तो जो स्टैंडर्ड नैपसैक होता है वो क्या होता है कि आपके पास एक वेट एरे दिया रहता है, वैल्यू एरे दिया रहता है, लेट्स से 4 5 6 एंड 3, एंड यू हैव 30 एंड 50, राइट? एंड आपको वेट करना होता है 10, राइट? तो स्टैंडर्ड नैपसैक यही बोलता है कि आपको you need to pick up weight which should be less than equals to your given weight in the maximum profit, right? मैक्सिमम प्रॉफिट आना चाहिए. तो मतलब कि आप कैसे उठाओगे? देखो 6 और 3 भी उठा सकते हैं बट उससे प्रॉफिट क्या आएगा? 80 आएगा. हमें मैक्सिमाइज करना है, राइट? तो हम क्या उठाएंगे? 4 उठा सकते हैं एंड 3 उठा सकते हैं. इससे 50 प्लस 40 90 आ जाएगा. तो सिग्मा ऑफ वी इज 90 एंड सिग्मा ऑफ वेट वुड बी 7. तो ये उतना यार अपना नैपसैक, स्टैंडर्ड नैपसैक है, राइट? अब हमारा जो क्वेश्चन है, हमारा क्वेश्चन कुछ इस तरीके से, हमारे पास कॉस्ट एरे गिवन है एंड वी हैव सम cost that is 20 10 4 50 and 100, right? And there's one more constraint that it all has an infinite supply. And if you mark the indexes as 0 1 2 3 4 and 5, then that is something as n, and the weight is given as 5, right? So we need to find the minimum cost in our case, right? So that the question says. And if you see, if we have to make the weight as 5, then definitely what we can pick this combination, that is 3 plus 2, which will give the weight as 5, and the cost would be 4 plus 10 14, right? There is another way. If we pick, since there's an infinite supply, so we can pick 1 which corresponds to 20, we can pick 2 which corresponds to 10, and again a pick 2 which corresponds to 10, right? So the sigma of weight would be equals to 5 and the cost associated with it would be 20 30 and 40, right? But this is not the minimum. We want the minimum, right? So here goes an input and output. So let us understand the second input as well. So what it says, that let's say you have n equals to 5 and the cost of array is -1 -1 4 3 and -1, right? Again the one base indexing, so 0 1 2 3 4 and 5, and the weight is 5 again, right? So there's only one way, or I don't think there's another way. Either you have picked this packet of weight 3 cost as 4 and you have picked this packet, but you cannot pick this one because the cost is the cost of 2 kg packet is written as -1, so we cannot pick this one, right? So there is no possible combination where we can pick an oranges which can have a cumulative weight of 5 kg, right? So in this case the answer is -1, right? How can we solve this question, right? उससे पहले we understand that why it is a variation of knapsack, right? So do you know that there are certain knapsack types? So one of them being 0 1 knapsack, right? So I'm just going to use some short abbreviation here. 0 1 knapsack, then we have a bounded knapsack, and then you have an unbounded knapsack, right? So what 0 1 knapsack means? So it basically, we can define these types of knapsack based on this thing, that number of copies available for for each item, right? Number of copies available for each item, right? So 01 knapsack says that you will have at most one, like either 0 or 1, at max 1, right? Bounded knapsack, it would say that you'll have some limited copies. Example, 3 copies of item A or 5 copies of item B, something like this, right? And unbounded knapsack, you means in unlimited, infinite supplies of each bag, right? And that is why, since the question says that we have an infinite supply, so this is a variation that now this has become an unbounded knapsack problem, right? I hope that makes sense. ठीक है, so what we need to understand in this case, तो हमारे पास, so the weight we have been given. So how many points did we discuss? So this was point 1 and this was point 2, and let's this is the point 3, right? So weight is 1, 2, 3, 4 and 5, and the cost associated it is 20, 10, 4, 50 and 100, right? And we need to make a cumulative weight of uh, n, let's say, equals to 5, right? And as we discussed that there would be multiple formations, and the minimum the formations will give us the minimum cost would be this one, right? So the one thing is clear, that we need to find all possibilities and keep track of minimum, right? This is the only thing we need to do to solve this problem, right? Keep the track of minimum, and इसको हम कैसे कर सकते हैं? There is none other way than the recursion itself, right? So what would be the recursive call now? Now, so I can think of two cases that my current weight, right, is less than equals to weight capacity. So I'm going to explain to you one by one. And my current weight is greater than my weight capacity. वेट कैपेसिटी वो कैपेसिटी है जिसको हम पिक करना चाहते हैं, इतनी की हमें रिक्वायरमेंट है, जैसे n equals to 5, so this is my requirement, that is my capacity, right? So once I have picked something, and this is my current weight, once I have picked something from my capacity, let's say I picked this 3, then my capacity decreases by 3, so 5 minus 3, 2, right? So that is the convention here which I'm following, abbreviation here which I'm following, right? So now there are two options. Either you pick a bag and you do not pick a bag. So there is a two recursive call, either to pick it and you do not pick it, right? So I'm going to say to pick, we say choose, right? And if you choose it, since there are infinite supplies, if you choose a particular bag, then you can choose that bag again if you have your capacity greater than your current weight, right? So I'm going to say, since copies are infinite, right, then we can choose the same. We can choose same bag or weight again, whatever we say, right? Whatever you say. Okay? But in this case, what would be your recursive call? What would be the recursive call look like? So let us finalize the parameters. So let's say we make a helper function or a cost function or a minimum cost function, whatever we call it. And we have this cost array given as first parameter, the capacity, which is first as n, and your current weight, right? And current weight, right? I'm just gonna say weight. ठीक है, हाँ, I'm just gonna say wait. तो if we choose it, then what will happen कि जो भी choose आपने किया, right, you need to take that cost first of all. So cost of n I would take, and my helper function, or let's say your function, how the parameters will behave. The cost array remains as it is. The n remains as it is because this n is nothing but the index. That means I am at this 5. If I have picked the bag of n equal the fifth bag which cost me 100, I can pick it again, right? So since I'm choosing it, so I have to check कि वो bag को वापस उठा सकते हैं कि नहीं. That is why I'm not doing an n-1 here. और हमारा capacity decrease होगा किससे? Weight minus my current weight, right? थोड़ा सा और बॉइल्ड लाइन करूँ तो ये करंट वेट किसको अप्लाई करेगा यार? दिस इज माय n, right? So if I'm choosing n, तो zero based intention, this is actually 0, 1, 2, 3, 4, right? And this 4 is actually pointing to this parameter, तो 4 plus 1, 5, right? So basically my capacity would decrease by my current weight, which would be nothing but n plus 1. बिल्कुल सही बात है यार. And not choose. If we do not choose it, then our function remain as it is. So function of cost, comma, n minus 1, because we're not choosing that bag, and we need to recur back for all the other options. So n minus 1, and the weight remains same since we have not chosen it, right? Now, question says to find the minimum of it. So we will just call a minimum function of these two recursive call, right? Correct. एंड इफ माई करंट वेट इज ग्रेटर देन माई कैपेसिटी, जो कैपेसिटी हमें चाहिए था, इतना हमको चाहिए था, राइट, बट जो करंट वेट है दैट इट सेल्फ इज ग्रेटर, दैट मीन्स हमारे बैग को, बैग में से तीन ही जगह थी, हम उठा रहे हैं a bag with capacity 5, right? तो फिर ये पॉसिबल ही नहीं है. In that case, we will recur for all of the rest of the options. So again, the same recursive call would be there, that function of cost n minus 1 comma weight, right? These would be the all recursive call. Now let us talk about some base cases. तो ये recursive call end कब होगा यार? Recursive call end तभी होगा कि हमारा जो capacity है, जो weight है, ये zero हो गया finally. We do not need any other bag or item to be picked up, right? So our base case would look like something this. That if my weight is equals to zero, then in that case I would say that I have found a particular answer and just return zero, right? Now, if n is, let's say, zero and weight is not equals to zero, in this case I would say we still need some capacity to fill my bag, but there are no values left, there are no available items left to be picked up from, right? So in that case we will just say it's not possible and return some value which is, let's say, integer dot max value, right? Okay. इंटीजर डॉट मैक्स वैल्यू क्यों रिटर्न किया है यार? क्योंकि देखो, अगेन हम इस रिकर्सिव को जब मेमोएशन में लिखेंगे तो मेमोएशन एरे में बहुत चीज है. अगर आप पहली बार मेमोएशन का वीडियो देख रहे हो यार तो अटपटा लगेगा सुनने में, पर ठीक है, मेमोएशन में जब मैं बताता हूँ इसके बाद, let us write this code first and then we will see. Okay, so let us switch back to our main screen and start writing the code. So let me increase the font size to 20 pixel. Okay, so I'm gonna call a helper function. So let's say int helper, and we'll have the same thing. So int cost, then you will have an int n and int w, right? So base cases were the same. So if, or let us write some recursive call first. So recursive calls, right? So so we would having a take case and a not take case, right? And this itself would be under one if, and this would be under one else, right? हमने ये डिस्कस किया था यार. तो ये केस कब था कि if current weight is less than equals to weight capacity, right? Capacity. So let me write it like this, capacity. So let me comment it, and now I'm gonna write in terms of coding, in terms of parameters. So what I can see is that my current way is nothing but the indexes. So if n plus 1, if n uh, if n plus 1, this whole into if statement is less than equals to if less than equals to my given weight, that is capacity, right? And the cost is not equals to minus 1, is not equals to minus 1, right? Then we can pick this bag up. So I'm gonna take two calls, take and not take. So take would be nothing but our helper function with the same parameters, that is cost comma n comma w minus that means our current capacity minus the bag which we have picked, right? So minus n plus 1, right? And the not take would be nothing but helper helper of cost comma n minus 1 comma w, right? And similar would be the case for else case, right, where our current weight is greater than capacity, right? So we need to return the minimum of this, right? So we need to store it into a particular integer. So I'm gonna say int take here, and I'm gonna say int not take this one, and I'm gonna say return math dot min take comma not take, right? Now let us come to the base cases. So base cases was that if w is equals to 0, that means our capacity has been filled. Don't matter that if n equals to 0 or if n is not equals to 0, doesn't matter. हमारा backfill हो गया, that means we got an answer, and we just say stop the recursion, return 0. but if our weight is not equal to 0 and n is less than 0, right? So this if n a second if already ensures that my weight is not equal to 0, because if it would have been 0, it would have been caught by this first if statement, right? So in that case, I'm gonna return some value, some integer dot max. देखो मैं ये क्यों रिटर्न कर रहा हूँ यार, दो बातें हैं इसके इसके पीछे। तो पहला बात ये है कि हाँ, लेट मी राइट इट फर्स्ट। हाँ, कि वी नीड टू ट्रैक द मिनिमम, राइट? तो इसलिए हम यहाँ पे जब आंसर पॉसिबल नहीं है तो वी आर रिटर्निंग द मैक्स वैल्यू। वन थिंग ऑल्सो वी नीड टू मेक श्योर कि इफ दिस फंक्शन हेल्पर बाय एनी चांस नहीं, पॉसिबिलिटी है कि ये इंटीजर डॉट मैक्स वैल्यू रिटर्न कर दे व्हेन इट हिट दिस बेस केस, राइट? सो एंड हियर देयर वुड बी वन मोर पैरामीटर, राइट? कॉस्ट ऑफ एन। तो कॉस्ट ऑफ एन प्लस इंटीजर डॉट मैक्स वैल्यू करोगे तो हमें एक नेगेटिव वैल्यू मिल जाएगा, राइट? सो वी नीड टू टेक केयर दैट एज वेल। सो थोड़ा सा इसमें चेंजेस करेंगे। सो आई एम गोना से इंट take is equals to integer dot max value here, right? And I'm going to store this recursive call in int temp, and then I'm going to check that if temp, if it is if it is not equals to this value, then only do the addition, right? So I'm going to just remove this line also from here. So now take would be updated as cost plus temp, right? And then not take is fine, and then we can track the minimum, right? So suppose in this case कि अगर हमारा जो ये helper function है वो integer dot max value return करता भी है, तो यहाँ पे देखो math dot min उसको handle कर लेगा, integer dot max value comma not take. So ultimately it will take the value from the not take one. So that is why this integer dot max value had to be taken care separately. ठीक है. I think we are good. Yeah, I think we are good. Now let's call this function here in the main class. So I'm gonna just say int n is equals to nothing but cost dot length, right? And I'm gonna call the answer. So int answer is nothing but this helper with the cost array. And we started from the last index, let's say, so n minus 1 and weight, right? And I'm gonna say return answer. And if it is equals to this value, then definitely the answer is not possible. So an inline if would help. So if that is the case, -1, else return answer. Right? I hope the recursion and things make sense to you. So something is wrong. So one extra basis over here. So compile and run again. Okay, so reach the end of the file. Let me rectify. Okay, so I think, yeah, one return is missing here. We just called the function, but we never returned, right? So return this. Now this should run. Best. And okay, tail again. The reason being that for each and every element we have two choices, right? So if we take and do not take. So the complexity would be exponential, and 2 power n would be the time complexity for this one, right? So, and that is the reason if you look at the constraint, maybe n is pointing to how much? N is pointing to cost of I, cost of size, 2 into 10 power 3, right? So 2 power 2 into 10 power 3, it's much more greater than 10 power 8. And we need, in order to have a successful submission, the time complexity should be, or let's say the number of iterations should be less than equals to 10 power 8, right? So we need to memorize it. So let us come back to our tab section. And memorization करने के तीन तरीके, for memorizing a particular recursive solution, we need to analyze the changing states. Right? Once we analyze it, let's say number of states changing are x, right? So we need x dimensional array, right? And we fill this values with fill this array with values that are not the answer at any possible stage, right? And once that is done, then before making a recursive call, before making recursive call, check array, right? And once you make the recursive call, store in array. By following these 5 steps, even though you do not complete a join for your memoization approach, you would be able to get through it, right? So I'm gonna do the same approach. Okay, something has happened to my screen. Just wait for a minute. Mhm. Okay, so the first point was let us analyze the states which are changing. So कैसे check करेंगे? So what are the parameters that we pass into the recursive function? It is cost n and w, right? And n is decreasing. I can see n has been decreased to n by 1 and further. And w is also increasing, or I mean decreasing, I mean changing, w minus n plus 1. And the cost remains as it is. That means first step was analyze the changing state. So there are two changing states. That means we need two-dimensional array. So let us make a 2D array and initialize it. So dp is nothing but equals to new int n and w plus 1, right? So I'm gonna write this thing here, right? Third step was to fill the array with such a possible value which can never be an answer at any particular stage, right? तो हम देख सकते हैं, हाँ, इस केस में कोई भी नेगेटिव इंटीजर्स फिल कर दो, -1 -2 -3 एनीथिंग, दैट वुड नेवर बी अ पॉसिबल आंसर, राइट? तो हम यहाँ पे -1 से करते हैं, आप -2 से भी ट्राई कर सकते हो, इट विल वर्क. सो फॉर इंट x in this dimension 2D dimensional array, so I'm going to say arrays dot fill x comma -1. Okay. Third step was to fill this array. I got this call. Before making a recursive call, we check it, right? So since we have made this a global array, so we do not have to pass it as a parameter. So before making a recursive call, so when are we making a call? So this is the recursive call, right? So before making it, I'm gonna just check that for parameters. You are calling the recursive call for n comma w, right? So if it is not equals to -1, then definitely we do not need, and we must have stored the particular answer. So return dp of n and w. ठीक है, मैं थोड़ा सा और बताता हूँ यार. देखो, रिकर्शन में क्या होता है कि ओवरलैपिंग सब प्रॉब्लम्स को हम लोग सॉल्व करते हैं. एक ही प्रॉब्लम को बार बार सॉल्व किया तभी हमें टीएलई है, राइट? यहाँ पे हम वही चीज करते हैं. अगर एक प्रॉब्लम को एक बार सॉल्व कर दिया, वंस यू हैव सॉल्व्ड अ पर्टिकुलर प्रॉब्लम फॉर द फर्स्ट टाइम, देन स्टोर इट समवेयर. इन आवर केस इट इज अ टू डायमेंशनल array, right? So, and that is why before making a recursive call, let's check that for that particular state which you are calling a recursive call, if that is already done in past, then just check it. If it is equals to -1, then definitely that has been stored, and we just return from then and there, and we skip those iterations. Now, when I say you check if it is not equals to -1, that means it must have been solved in past, right? So that means the point in the past where it was solved, you need to save that as well, right? So there goes our fifth point, and I'm gonna say while you are returning, just try to save that thing. So I'm gonna say here, return this and this, right? And that is it. I think if we just hit compile and run, it should pass. Depending should not be converted into Boolean. When did I convert it to Boolean? Okay, not equals to -1, right? So it would be not equals to. Let's compile and run one more time. Voila, great. So Monday आ गया यार. Tomorrow I need to go office as well. So let us compile, wrap this video. I think the video intuition problem solving live coding helped you in a way that you would be good to go for your interview preparation and practicing one problem a day. And that is it from my side for today. Till then, keep learning, keep going, bye, and take care. Do not forget to check out our other playlists. We document everything from my study journey and what do I do in my life as well. And that's our DSA repository starting forward below the source code. And that is our DSA 360 sheet जो मैंने शुरुआत में solve किया था. And then I keep on solving one problem a day. That is it. So bye, take care, guys, and we'll be in the next video.